Chain reaction would cause an effect. Makes you turn around. Makes you try to explain. Makes you forgive and forget.
Hello everyone out there, it's Adam Fleischhacker coming at you today to unify narrative, math, and code. The larger narrative we're going to pursue over a sequence of videos is whether we can design a spinner, the kind you would see in a Twister game, to have different outcomes land with different probabilities. Today we're going simple though. I'm a beginner in Julia and we're going to do a beginner's walkthrough. Today we'll just use our math will be trig and our code will come from the great Luxor package within Julia.
Would you change if you knew that you would find a truth?
All right, today we're going to find ourselves in Visual Studio Code because I just find it easier for these prototyping workflows to be in VS Code as opposed to a notebook like Pluto. So let's explore VS Code. It says to get started, we can open a folder or create a new file. Let's open a folder. In Visual Studio Code, your folder becomes a really important directory. So we're going to want to store all of our stuff somewhere we can remember. So I will create a new directory in my C drive, new, and I'll just call it spinner. And this way everything will be in spinner. I'm going to select that folder and this will become my working directory. So now from here I can add new files. And the file we'll call it spinner demo.jl. And by adding the .jl extension, it loads the editor so that Julia keywords will be recognized. See how using is in purple there. Notice I needed some extensions to make this happen. Extensions are here. Here are my installed extensions. The Julia extension is the only one you need. Going back to editor. Drawing a static spinner. We're not actually using Julia. We're going to use Luxor to draw our static spinner. I encourage you to heavily comment your code. Here is me saying I would like to draw a spinner. From my previous work in Luxor, I like this macro called draw because it's just going to create a PNG file in memory. It won't save anything to disk. And I will draw a circle for my spinner, centered at the origin. And since the default drawing is about 800 by 800, I am going to set my circle radius to 210. And I have to use the stroke action to say, actually draw the circle. Don't just think about the circle. In VS Code, if you run Alt-Enter, it runs the entire block of code. At draw not defined, I ran this block before using the using Luxor block. So I'll Control Enter on using Luxor to run the line, and then I'll Alt Enter to run the entire block of drawing. And there I have my circle. So awesome. We got to start now. So now we just iterate. This is not exactly the spinner I had envisioned. You saw the spinner I created was that orange one. So we're going to create that orange spinner that I've been giving hints about. First thing you might notice is the background is this horrible bright white. So background takes an RGB code with alpha being the transparency term. So I'm going to create a black background. And then I drew a black circle on a black background so I don't get anything exciting. So let's set our hue, I never say that right, orange, and Alt Enter, and there we go. Okay, so I'm a little concerned that the line is not thick enough. So there's a function set line to change the line size. Alt Enter. Nice. I got a thicker line. I got a good looking outer perimeter of my spinner. Now, the next thing I'm thinking is I want to draw my little spinner arrow to say where it's pointing, but that arrow is going to need to change direction. So I'm going to use a different function for creating the arrow where I could say point in a certain direction and a different function for drawing the spinner. So let me take all this awesome code that I just did, Control X, and paste it up here. Function to create circle. So we have these 4 lines, and now I want to make it a function. So I'm going to do function draw spinner circle. It will take one argument called circ_radius, which will be a real number, and I'm going to set a default radius of 210. Now all this stuff should be indented, so I press tab and move it over, and then end. So here is now a function that draws a circle, and oh, here I'm making the radius changeable, so I will change it, and this should draw my circle, and then I can call the function down here to draw it. With a given radius. So let's first try to draw it with a smaller radius, 50, and see if it comes out smaller. So I Alt-Enter to put the function in memory, Alt-Enter again, draw my smaller circle, take away the argument, get my bigger circle. Cool, we're on our way. So now let's create a function to create the pointer. For now, I'll have no arguments to my function. I just want to draw a line on the screen to make sure it comes out. So I know there's an arrow function in Luxor. If I hover my mouse over the name in VS Code, it will tell me what I need to use the arrow function. So we see that the first 2 arguments are a start point and an end point. And then there are some keyword arguments. Keyword because they're after this semicolon. So if you want to use line width or arrowhead length, you need to specify by name, not by position, the function argument value. So I couldn't just enter a start point, an end point, and then a line width. I actually have to say line width equals something. But for now, I just need a start point and an end point. Okay, I can define those. So my starting point could be the origin. My end point, let's see, I have a 210 radius circle. So maybe I should make a radius argument here. So I'm going to copy and I'm going to call, we'll call it pointer, that we'll call it end radius. And we'll default that to something shorter than 210 so we can actually see the arrow. Let's just do 0, and radius for now. And we'll have to refine this, but I'm just trying to get something working, something simple, and then I iterate and get more and more complicated. If I try to get too complicated all at once, I end up with errors and bugs, and then I have trouble debugging my code. So here, I just want to get a pointer on this silly circle that we see to the right. We end the function, Alt-Enter to register the function, Alt-Enter, oh, just draws the circle. I need to call my function draw pointer. Hey, that was pretty cool. And it reminds me that, oh, a positive number for y points down, the y-axis points down. Now, I've got several complaints about this pointer. The line is not wide enough. The arrowhead, I can't see that. So I'm going to go add some of those keyword arguments I talked about to the arrow command. All right, let's see how this runs. Ah, that looks much better. Much happier with that pointer. Excellent. But now the pointer points straight down. We want to be able to point to any value on this spinner. In fact, let's define some values for the spinner. So I'm going to go back up to drawing my spinner circle, and I'll put some measurements on the circle so we know what we're talking about. You know, if I was a mathematician, I'd use degrees or radians or something for my spinner. But in the real world, we're modeling a real world spinner. My twister spinner doesn't land between 0 and 2 pi. So we're going to put just a spinner that goes between 0 and 1. That's easy enough for us in the real world, us normal people, to understand. We'll use the text function. Let's see if that works. Alt-Enter. Oh, no. Syntax unsupported assignment operator : equals. I should do equals the symbol bottom. The colon equal sign is exactly what you think it is, but the colon means a symbol. So the symbol bottom or the symbol center, Alt-Enter. Now I don't see anything. That's weird. Now after some thinking, maybe I'm drawing this orange 0 right in my circle radius here. So what if I add +20 to the circle radius? Make it bigger. Let's see what happens there. Oh, missing comma. Forgot to close my point. Extra parenthesis. Here we go. Ah, there, look at that tiny little 0. Plus, it's in the wrong place. I wanted to put the 0 on top. I always forget that y goes down. So we're going to make this negative circ radius plus 20. And let's increase the font size dramatically. Ah, much better. 0 up top there. Okay, so 0's up top. This will be a quarter, a half, 3/4, and all the way back to 1. So we're spinning between 0 and 1. I'll quickly add some extra measurement marks. Excellent. So now I put these measurements so I know what I'm measuring. And now when I could draw my pointer, I want to be able to pick a value somewhere between 0 and 1, and the pointer points to that value. I'll make that value an argument, and I will call it theta. And I've gotten in the habit of specifying types in Julia. You know, Julia, all the help documentation is all type-based, so you got to get familiar with types in Julia. So I try to use them all the time. Whether I'm using them correctly or not, who knows? But I'm saying theta is going to be a real valued number. And now I have to do some math for the coordinates. The pointer will always start at the origin, but the end is based on this theta value. Running through some trigonometric combinations and iterations. Google Grant Sanderson's video on the unit circle. It's awesome. 3 blue, 1 brown. I'll show a link in the video. But after some calculations, I can figure out the x and y coordinates for the endpoint of this arrow based off of what value for theta we're trying to point at. And if I do \pi tab, I get the pi symbol, and that's a constant pi. So I have to do some trigonometry myself for the drawing, but I'm going to hide that from my communication. My narrative of the drawing in the real world needs to know nothing about pi, right? The spinner goes from 0 to 1, not 0 to 2 pi in the real world. In the fake world here, yeah, we need to know something about radians. The second coordinate is n radius times sine of theta minus 0.25. Just clean up the formatting here a little bit. Let's see if that works. So draw pointer now needs a theta value. And based on that theta value, it will determine the endpoint of this arrow. Notice if I'm surprised that worked because I didn't specify a theta value and draw a pointer. It pointed straight up. Is there a theta value hidden somewhere? Undefined. Huh, who knew that? Let's see if I draw the pointer for 0.25, if it'll go to the right now. Yay. It works. Keep testing. And what if I did a number outside of 0 and 1, like 1.5? It just goes to 0.5, which is actually nice. So we can think of theta as measuring the distance around the spinner that it went, and 1.5 means it went 1.5 times around. The theta is like the revolutions of the spinner, 1.5 revolutions. All right, I'm going to collapse my function draw spinner circle and draw pointer to unclutter my workspace here. We drew the spinner successfully, which was pretty cool. But now we want to animate the spinner.
How bad, how good does it need to get? How many losses, how much regret?
So I will show you 2 ways to animate the spinner. The first is the way that makes sense to me initially, and the second is the Luxor way, which is really cool, but will require you to go to the Luxor documentation to remember what you're doing. So here's my thinking. Let's create a loop over theta, a for loop, that goes from, we'll do 2 revolutions. So it goes from 0 to 2 and the step size equals 0.1. Let's just do a little loop like that. Or let's even 0.1. Let's see what that loop. So I'm going by hundredths, going around in circles in this for loop. And what I want to do in the for loop, just like a little flip book, I want to draw with each loop through, I want to draw a frame or a scene on the right that shows this little spinner rotating. So 1.5 is not my angle. I want to go theta. So I draw, oh, I need the whole thing here. I need the @draw macro. So, and then we do theta. And the for loop, we run this. Invalid iteration specification. Oh, I forgot the keyword. For theta in range 0 to 2. Let's try that again. Run it. You can see it's evaluating, but I don't see anything. Maybe it's drawing so quickly, or I'm not sure where the output is going. There's all this stuff it took me a while to figure out. Well, because the arrow didn't change, I think my output is not going to this plots pane here. It's inside the context of this for loop. Who knows where the output is going? With some Googling, you can discover that if you want the output to the display in VS Code, use the display function, and preview recalls the last drawing in Luxor. So the display function makes sure it gets output to the top of the display stack, which in our case is the plots pane. So now if I run this, let's see what happens. Oh, I saw some movement of the arrow, and the arrow moved up, so it is displaying, but it seems like it's going too fast. So if I just use the sleep function here, and I could put a really small number of seconds, 1/1000th of a second, you'll see as soon as I do that, you're able to animate the spinner, and it goes around. And we said we're going to go 2 loops from 0 to 2, so it should go around a second time, and then be done. Now, I've never seen a spinner with this linear type of speed, so we're going to use functions from Luxor's animate function to make it look more like a spinner. Starts out fast and gets slower. But to use the Luxor animate function, you have to use the movie function to create an object that is basically going to refer to the movie you're making, one frame at a time. So we'll use the movie function from Luxor, and it asks for width, height, and movie title. Okay, I can give it width, height, and movie title. So let's do 600 by 600, comma, spinner will be the movie title. Alt-Enter. That seemed to work. Excellent. Now, you're going to compose scenes in your movie using functions. Each function will take 2 arguments, scene and frame number. This is standard. So I'm going to call one function background. You could call it whatever you want, but it's just going to paint the background, which is this black color that we're using. So background 0, 0, 0, 1. And this will draw our background. Luxor.background must be explicitly imported to be extended. Oh, I'm calling the function background. I should call it something else. Backdrop. A different name. Okay, good. And we use the background function. And then we're going to make another function which is going to draw the action. And we'll call that frame, following the Luxor documentation. And again, it's a 2-argument function. So in each frame, we're going to draw the spinner circle. And we're going to draw theta. And if we do, say, 400 frames, we can make this pointer frame number divided by 100. So 400 frames, the spinner is going to go around 4 times. Okay, Alt-Enter on that function. It worked. And now for the magic of the animate function, we're going to animate our spinner movie. Is the first argument, is our movie. And then we're going to specify the scenes, an array of scenes. So we use the opening bracket, press enter. So the first scene, and the scene is a function in Luxor. We say which movie do we want it to be a scene of? What function are we calling to create the scene? And which frames? We're going to do a 400 frame movie. So from 0 to 400, that's actually a 401 frame movie. But we start at 0 this way. The initial scene is 0, and then the action starts at 1. You can think about it like that. So the initial, on all 400 frames, we're going to draw our background. And we're also going to draw, using the frame function that we just created up here in line 51, frame function, from 0 to 400. And then we'll close the brackets for our frames. And then we'll pass a few more arguments to the animate function. One is going to be frame rate. So if we're doing 400 frames and we do 40 frames per second, we should spin 4 times in 10 seconds. That sounds cool. Let's do that. I can supply a path name argument so that this gets stored as a GIF file. And it will get stored in my working directory, which is spinner here. We'll see it over here on the left. And I will say create GIF equals true. So it will display the animation in my plots pane, and this create GIF equals true. Notice if I look at the animate documentation, I did have to install this FFmpeg utility. So there are good YouTube videos on that and getting that running, but that will help you create the GIF file. So Alt-Enter, it says evaluating down here, seems to be doing things. Frames for animation. Still thinking for a while, and part of that is compiling these functions that I haven't used yet in my Julia session. The next time I run this animate function, it goes much faster. Cool. And now we have our spinning spinner, which looks pretty smooth. Doesn't stop, but it looks good. And we have our spinner.gif got stored in our working directory. Pretty cool. We've animated a spinner. And the reason it keeps going around and round more than 4 times is the GIF keeps repeating itself. My next inclination is to make this spinner behave more like a spinner, start out fast and then slow down. So we can use Luxor's easing functions to change the rate at which we're showing different frames so that frames at the beginning are showed in rapid succession, or at least we feel like they are. And then at the end, it slows down to near 0. So instead of drawing this frame function, drawing as a function of frame number, I can use a scene. So remember, scene is going to be one of the arguments passed to this function down here in the animate command. So I'm going to take scene and apply an easing function to it, which is a function of frame number. And I have to tell it that you're taking these 401 frames from 0 to 400 and going to change the rate at which they get displayed all the way until the animation stops. And like the Luxor documentation, I will call this eased n, and then I will use this eased n instead of frame number to say which way the pointer points. And let's see if that creates, oh, we need one more thing. We have to specify when we draw the scene in the animate function here that we're using an easing function. And the easing function we're going to use is called ease out quint. So it starts out really fast and decelerates at the end. Let's try it. Alt Enter. And there we go. So at the start of it, it gets kicked off. Bam! Spinner go. And then it slows down on the 4th revolution to 0. And what this makes me want to do is show the outcome, the point the spinner is pointing to, when it comes to an end. Because it's not clear of all the infinite points that it could be pointing to, what point it is pointing to, even though it's 0 in this case. So I'm going to make a function up here to put the outcome of the spin on the screen. So we'll do function draw outcome, which will take the theta value and put it on the screen for us. So let's draw the outcome in big numbers. We'll do font size 50. We'll do a shade of gray for the font color. And we'll use the Luxor text function to put, theta is going to be a number. We're going to want to make it a string. So let's do text to add. And I'm going to use a little trick here. In Julia, you can use print formatting like you can in C, which sounds like a terrible thing because C is really hard. But I'm going to scroll up. We're going to use the printf package, which comes in Julia. It's a sort of standard expected functionality. So using printf. And then I can say that the text I want to add follows a certain format. So the format that I want is 3 decimal places. And the format of that text string, that's going to, what it's going to convert to 3 decimal places, will round theta to 3 decimal places. And digits here is, again, one of those keyword arguments. You have to say digits equals 3. You can't just rely on its position when calling the round function. So let's just make sure that this looks good. Sprint F. It's sprint F. Okay, so that's the text to add. And then we use the Luxor function text to add, which by default will get drawn right at the origin, which is good. So let's just make sure it's drawn in the middle of our circle and the center horizontally. All right, so we have function draw outcome there. So let's test our draw outcome at 1.5. Let's see what happens here. And we get 1.5. That's pretty cool, except I really don't need to know the number of revolutions. So a quick way to do that, let's say spinner position, not sinner position. We're not talking about sinners. We're talking about spinners. Spinner position. A quick way to do that would be to take theta and get rid of the integer component of theta. That will get us just the decimal portion. And then the text to add is rounding spinner position to 3 digits. Alt Enter, and there we go, 0.50. Let's bring this logic to our Luxor animation and see if we can make it work. So in our frame, we're going to draw the pointer, and then I'll get a little fancy here. I'll say if the frame number, once we're halfway through, then start drawing the outcomes. And our outcome is the eased n divided by 100, right? That's where my pointer is pointing, so that's where my outcome is, and an n function here. Alt Enter. All right, let's animate moment of truth. Animate it. All right, the spinner's spinning. And the outcomes come in. Hey, that's pretty awesome. Congratulations, you've made a spinner. This code is available on GitHub at this link, so check it out, and good luck making your own animations in Luxor.